But if not, then you can still ask questions based on what you hear during the presentation. So I see the big hand is pointing straight up. So we will begin. Our first talk will be presented by Chao Liu, Code Matcher, search code based on sequential semantics of important query words. And you may take it away and share your screen.
Yes, is that okay? Can I start now?
Yes, go ahead.
Sure. Hello, everyone. I'm Chao Liu from Chongqing University, and I present our work, Code Matcher, searching code based on sequential semantics of important keywords. While searching and reusing existing code from large-scale repertoire can improve software development productivity. As we can see, the GitHub always returns numerous irrelevant and useless code. And our goal is to fuse the advantages of information retrieval model and the deep learning model. We observed that the information retrieval model search very fast, but the accuracy is bad. But the deep learning model works slow, but it has three advantages, such as understanding relevant noise keywords, capture sequential relationship between words, and matching relationships. And our goal is to use these advantages. So we present our code matcher. From step 1 to step 4, it builds an indexing like information retrieval based models. And from step 5 to 7 to 8, it likes the deep learning model, says collect metadata, address irrelevant words and stem words. And for the step 9, we search some candidate code from the indexed code base by using the fuzzing search. And finally, we remove some redundancy and re-ranked the code according to our designed similarity measures. And here's a simple example. And with the query convert an input string to a string, we first analyze collect the metadata such as property, frequency, and importance. And then we search the code from the code base from different ways, and re-ranked the code and put the first code to the first. And then we compare code matcher with three baselines and tested on our large-scale code base with over 60 million Java methods. And our experimental results showed that code matcher outperforms two deep learning models and one information retrieval models significantly. And code matcher runs fast. It only needs 0.3 seconds for an query and needs no time-consuming training as information retrieval model. And all the components are necessarily required. And we also showed that our code matcher outperforms GitHub and Google search. We analyzed why the code matcher works. And we found that in most of the cases, code matcher works because they can successfully match the semantics of query and method names. We check the conciseness and the completeness of the returned code. Can show that it also shows better performance than the baselines. We investigate why the deep learning model not works well on our code base because of the larger scale of code base and especially the out of vocabulary issue. And we analyzed the importance of a word sequence. We found that most of the queries is important, such as the verb phrase and the and for these four cases, and many models didn't consider this issue. And that's our work, code matcher. Thank you very much.
Thank you. Okay. So next we're going to move to the talk, The Best Defense is a Good Defense, Adapting Negotiation Methods for Tackling Pressure Over Software Projects. And Patricia Matsubara, you're our speaker.
Thank you. So I'm Patricia Matsubara. I'm a PhD candidate at the Federal University of Amazonas. And today I'm presenting the paper, The Best Defense is a Good Defense, Adapting Negotiation Methods for Tackling Pressure Over Software Project Estimates. And this paper was written, the co-authors are Professors Igor Steinmacher, Bruno Gadelha, and Tayana Conchi. And the context we have here is that in the software industry, we have estimators generating software estimates, but we also have people receiving these estimates. And estimators and receptors have to work together to establish commitments, which define the set of features we're going to deliver and the deadline, for instance. And rationally, we should base such commitments on the technical estimates provided by estimators, because they are the technical people with the knowledge and the competence, experience to tell us how long a test will take, for instance. But when we look to other fields of knowledge, such as behavioral economics, we see that humans are not necessarily rational all the time. And the same happens in this context of estimation and establishing commitments, because people work in organizations, and organizations have their own targets, which are desirable business outcomes. And each individual also have their own goals and agendas. And the software engineering literature shows that all these concepts are related in situations such as like this one, where you have estimates and targets colliding, and this leads estimators to feel pressured to change their estimates, for instance. We also see that time pressure is very common in the software industry, and time pressure is all about unrealistic commitments. Also, we have industrial surveys showing and connecting tight deadlines, again, unrealistic commitments, to technical debt. So in summary, we can see that the pressure over estimates impact negatively the quality of our products. So we asked ourselves, how to empower software practitioners to resist pressure and defend their software estimates? And we resorted to negotiation methods to try to answer that. But why negotiation? Well, taking a look at one definition, we can see that a situation is considered a negotiation every time that the people involved consider it to be a negotiation in the first place and prepare accordingly. They try to gain something from the interaction. They need each other to get the results they want. They won't be able to do it alone. They communicate back and forth, and they work towards an agreement. And we believe that this interaction of the generation of estimation and establishment of commitments has many of these characteristics too. So we studied 3 negotiation methods to devise an artifact in the form of what we call a set of defense lenses. And to understand a bit more about it, let's see one example. So let's suppose we have people making pressure over us for the delivery of a product on a tight deadline, because, well, that's problematic. And we aim with our set of lenses to change the attitudes and behavior of estimators of yielding to pressure to a more active behavior of trying to do something about it. For instance, one of the lenses that can help them is the reality test. It is based on the negotiation principle of educating the other people you are negotiating with and let reality be their teacher. So when we look at the focusing questions we have here, we are trying to create this change of behavior. For instance, in this situation, the estimator can ask these people about what they think will happen if they accept the deadline. And will this work? Well, we asked for software practitioners to use the lenses in a pressure scenario so that we could assess the perceived usefulness. And what we have is that participants used many of the lenses that we expected them to use in that scenario, and they found them useful. And another interesting result is that the person with the lowest assertiveness profile still felt uncomfortable with the situation, showing that there's still room for improvements in our artifact. But also the person with the highest assertiveness profile saw that the set of lenses actually helped him to gather arguments to defend his estimates. So what's next? Now we're working on a digital simulation to support even further these estimators in gaining the negotiation skills that can matter in such situations. And that's it. Thank you. Let me just stop here.
Great, thank you very much. Very good. Okay, so now we're going to move on to talk 3. This is Gunnar Kudjavets, the unexplored terrain of compiler warnings.
Excellent. Thank you. First of all, everybody, thank you for attending this talk. I know it's 5 minutes of your life, so I'll try to make it worthwhile. My co-authors are Aditya Kumar from Snap, Nachipan Nagapand from Meta Platforms, also known as Facebook, and Ayushi Rastogi from University of Groningen. So this talk is mainly kind of a sad reflection of our life as software engineers based on our collective experience from Microsoft, Facebook, Snap, and some other companies. So background is very simple. Software evolves on a daily basis. At some point, those changes cause compiler warnings to happen. And here comes the questions. What do we do with those warnings? So for example, do we fix them? Do we not fix them? Do we fix only some of them? And there are a number of things to take into account. So for example, not fixing the warnings may mean that we are missing on a number of bugs. Fixing all the warnings may be an investment which is not worthwhile. So let's see what's kind of happening in real life. Unfortunately, there is no consensus in industry, and even based on research. For example, Google pretty much disables all the warnings in a build output. Microsoft, depending on a team, you may have almost a zero tolerance policy, or you may have something mixed. Facebook uses a very, very data-driven approach when determining what to fix or how to fix. And the net result is organizational confusion. So you have developers moving between teams who get confused by the new rules, for example. And even inside the same organization, you have this kind of very classical debate. Should we fix it? Should we not fix it? Who's going to decide if we should fix warnings or not? Like anecdotal evidence, but I literally remember discussing this topic on every single project, on every single team I have ever worked in my entire life. Most of the guidance comes from gray literature. So for example, on books like Code Complete or Writing Secure Code. What we have also observed is that the more senior engineers are, the more inclined they are to fix warnings. So for example, people who have had experience spending days, weeks, or sometimes even months tracing down bugs which could have been prevented by fixing integer overflow warnings. They are much, much more receptive when it comes to putting in work and fixing the warnings. When it comes to zero tolerance policy, for example, making sure that warnings breaks a build or they're not acceptable. In industry, we kind of almost never see it. I mean, the only known evidence we have is projects like flight software or space software using this type of practice. So now, why don't engineers fix warnings? So first question, for example, you have 10,000 compiler warnings and you ask somebody, okay, can we fix it? Is show me the evidence, show me the data, and show me the proof. And at this stage, we don't have the data. We don't have proof showing that fixing compiler warnings conclusively causes, for example, defect density to be reduced. Second issue we see is distrust in the validity of warnings. So even small number of false positives kind of reduces this trust into compilers. Third option is impact on engineer's career. So for example, when engineer has an option to decide should they work on a known bug, so for example, a bug which causes Windows not to boot or improves Instagram performance or whatnot, or work on scheduled work items, there's a very clear return on investment. When it comes to compiler warnings, it's very hard to articulate, but What got better? Why is project in the better state than it was before? And also, cost of adapting stricter compiler warnings to legacy code. So for example, we integrate something into our code base, and it may take us 2 or 3 months to fix the warnings. So what can we do as researchers? First of all, explore the current state. Our study is based on industry, but we don't have very good insight what is happening inside open source software. Try to come up with some sort of evidence that shows that compiler warnings are beneficial or not, and conduct case studies about projects having zero tolerance policy towards warnings, just to understand, is this approach worth using or not? And I'm going to end my talk with this kind of general plea for help. This is maybe not the most modern topic. There's no AI, no ML, no blockchain on it, but it kind of affects each and single engineer I will know on each and single project they're working on daily lives. Thank you so much.
Thank you. Great. Okay, so number 4, Ewen Dong with SNR constraint-based type inference for incomplete Java code snippets. Take it away, please.
Cool, thank you. Hi, everyone. I'm Yuwen. This is my presentation about SNR, a constraint-based type inference technique for incomplete Java code snippets. Code snippets can be found in a variety of places: forums, Java docs, QA sites, like in the screenshot from Stack Overflow. Developers incorporate code snippets as part of their question to help clarify what they're asking for and get more specific help. And oftentimes, people also respond with code snippets to help illustrate their answers. But the problem with these code snippets is that they're generally incomplete. First, code snippets are generally syntactically incomplete. For this code snippet, we wrapped it with a class and method declaration to make it parsable. But this code snippet is still missing type information. We highlighted some of the missing types, like date format, date calendar. These are short names which allow the code to be written more concisely. And the fully qualified names for these types are generally specified in import statements, which are not here, nor is there any library information here to help guide us. Here's the code snippet after the import statements are added. And this code snippet is finally adapted for real-world use. In general, these challenges make it hard to reuse code snippets from the internet. In this work, we focused on using type inference to infer the fully qualified names of the types found in the code snippet, and use that to add the import statements to make the code compilable. Our unique insight for this work is to leverage the partial semantics of the code rather than resorting to machine learning-based approaches for type inference. Let's look at an example. Here we have a line from the code snippet before. From this line of code, we know a number of things. We know that calendar is a type with a simple name calendar. This calendar type has a method getInstance, which takes 0 arguments and returns a type with a method getTime that takes 0 arguments. The return type of getTime is a subtype of the type for the variable today. And today has a type with a simple name date. We can leverage this knowledge to help us infer the types in the code. We annotate the st with the type variables to show all the types used in the code snippet. Using the type variables, we can translate the earlier knowledge to these 5 constraints, like tal2 has simple name calendar, method getInstance with no arguments, and return type tal3. GetTime method is similar. Subtype constraint where tal4 is a subtype tal1. And we just need to solve for the type variables. To help solve for the type variables, we leverage a knowledge base, which we built from popular Java libraries, such as the JDK, JOLTime, and more. In this sample, we can see there's a calendar class with methods getInstance and getTime, which returns calendar and date. And there's a couple classes with the simple name date. These facts can help us solve the constraints from earlier. The knowledge base, in addition to storing method fields, also contain relation information shown in this simplified schema. So with these constraints and facts from the knowledge base. They can be fed to a data log system, which gives us a mapping from the types in the AST to the fully qualified names of the types which satisfy these constraints. Using constraint-based type inference, we can safely rule out SQL.date as the type for the variable today, as it will violate the subtype constraint since getTime returns util.date. To evaluate the performance of SNR, we gave 267 code snippets without import statements to get the mapping between the API elements and the top one recommendation for their fully qualified names. Using that, we calculated the precision and recall of our tool. We found that comparing to existing state-of-the-art tool Coaster published in ASC 19, which uses machine learning-based technique, that SNR outperforms Coaster with very high 98.2% precision and 77.66% recall. In summary, we introduced constraint-based type inference, a technique to automatically conduct type inference with our unique insight of using partial semantic information on code snippets. We evaluated our technique and found SNR outperforms existing state-of-the-art with high precision and recall. Thank you all for listening. Please check out the paper for more information. Thank you.
Thank you. Okay, next, our fifth talk is cross-domain deep code search with few-shot learning. Etienne Chai is our speaker.
Hello everyone, my name is Etienne Chai from Shanghai Jiao Tong University. Today I'm going to present our work, Cross-Domain Deep Code Search with Meta-Learning. The past few years have witnessed the rapid development of deep learning-based code search, in which a bimodal deep neural network is trained based on a large parallel corpus of code and natural language. The deep neural network computes the vector for both the query and code snippet in the code base, and then search code snippets based on their vector similarity. A major challenge for deep code search is the adaptation of deep learning model to domain-specific language. State-of-the-art code search methods are mainly designed for common language such as Java and Python. They rely heavily on the availability of large parallel data to learn the semantic mappings between code and natural language. Here is an example. A programmer asked the well-trained neural network for a code snippet using Solidity to sort an array. Although the neural network is well trained with a large amount of data, it can't understand well what is Solidity. A key idea to solve this problem is the few-shot learning. Few-shot learning is the machine learning technology that aims to quickly adapt a trained model to new tasks with a small number of training samples. Since deep learning models have already known how to sort an array in other language, we can simply provide a few samples to adapt the model for a new language. In this work, we propose CDCS, a novel cross-domain deep code search method using meta-learning. In addition to pre-training and fine-tuning, CDCS adapts a few-shot meta-learning algorithm called MAML to learn the good initialization of model parameters, which can best be used in a domain-specific language. The workflow of CDCS involves 4 steps. We first pre-training the model with a large corpus of multiple common languages, such as Java and Python. Then we perform meta-learning to adapt the pre-trained code representation model to the target domain. Finally, fine-tune the model on the code search task and evaluate it. The pre-training phase aims to learn representation of code and natural language from a large corpus of multiple common language. We pre-train using the task of mask-length model. Next, we perform meta-learning to adapt the pre-trained code representation model to the target domain. We employ a meta-learning algorithm, MAML, which is a typical algorithm for few-shot learning. It learns a set of initialization parameters using large data of common language, and then trains a new code search model on a small domain-specific language, starting from the found initial parameters. In the fine-tuning phase, We apply CDCS to the code search task in the target language. We fine-tune the model on the code search task, which is regarded as a binary classification problem. In our experiments, we pre-train our model on Python and Java, and transfer the model to Solidity and SQL. We compared CDCS with full baseline, and we can see that the CDCS outperforms the baseline models in terms of all metrics, especially the top one accuracy and MRR. We also present the performance of CDCS on the different datasets. As a result, show CDCS outperforms the baseline model on the all datasets, which supports the significance of the improvement achieved by it. In conclusion, in this paper, we present a cross-domain code search approach that adapts pre-trained model on common language to domain-specific language using meta-learning. CDCS demonstrates good strength in future learning for domain-specific code search. Oh, that's all. Thanks for listening.
Thank you. Okay, our fifth and final talk before we turn to our Q&A free-for-all is GitHub sponsors exploring a new way to contribute to open source. The speaker is Christoph Trud.
All right, thanks Rick for the introduction. My name is Christoph Trud. I'm at the University of Melbourne, and this is work that's led by a team of collaborators in Japan at Nara Institute of Science and Technology in Shinju University. And it's, as the title suggests, about GitHub sponsors. What is GitHub sponsors? It's GitHub's latest addition to its list of services aimed at ensuring the sustainability of the open source world, because many projects, of course, struggle if they are volunteer-driven to find the funding and to find the time to put an effort into these open source projects. GitHub sponsors has been around since May 2019, and at least as of now, during the first year of your membership of GitHub sponsors, GitHub matches contributions of up to $5,000. What makes GitHub sponsors different from other sponsorship mechanisms that are around in the open source world is that with GitHub sponsors, you can sponsor individual developers rather than projects. So as a member of GitHub sponsors, you can give donations to any other GitHub users. This is what a sponsorship profile can look like. This is my own. I have not made any money yet, but you can write a little blurb about yourself, and you can make promises what you would do if you receive a certain amount of sponsorship money. So since GitHub sponsors is fairly new, this paper describes an exploratory study, just trying to understand what is the current state of the practice of GitHub sponsors, and our research questions sort of reflect this. We wanted to know who are the participants in GitHub sponsors, what makes developers likely to receive sponsorship, and what challenges and benefits do they perceive that the current way of GitHub sponsors has. We answered these questions based on data from 3,000 and some sponsored developers, 5,000 non-sponsored developers. So those are people like myself who had enabled the sponsorship feature but have not received anything yet. 17,000 sponsors, people who have given money. And we also sent out a survey and obtained 372 survey responses. So let's briefly look at the first research question. Who participates in GitHub sponsors? And one way of looking at this is by plotting the graph of people giving money to each other. And in this case, color represents the different programming languages. And something we can see here is that developers working in particular programming languages tend to give money to each other. So we have a big cluster of PHP developers giving money to each other. JavaScript developers give money to other JavaScript developers or TypeScript developers, and other programming languages are a bit further apart. So there's a bit of clustering happening, self-selected clustering of sponsorship. We see a similar trend if we look at our second research question in terms of what characteristics make developers more likely to receive sponsorship. We answer this question using a decision tree algorithm. Details can be found in the paper. But basically at the very top level, we find that what distinguishes people who get money from those who don't is whether they are top contributors to repositories where there's already some sponsorship happening. And then at the next level, it depends on the number of repositories. At the next level, how popular the repositories are. And then we see that on the left side, people are fairly unlikely to be sponsored. On the right-hand side, people are fairly likely to be sponsored. So let's look at some of the challenges and benefits. This comes from the survey responses. The qualitative analysis is described in detail in the paper. For this presentation, I just picked out a few representative quotes to show you what kind of information is in the paper. So why do developers ask for money? One of the quotes is, why not mostly? It mostly boils down to recognition for the work since the monetary amounts are negligible. So the amount of money exchanged is relatively small, but it helps with motivation, as this next quote shows. It's made me feel a lot more motivated towards adding more open source code, paying a higher level attention to detail. And finally, why do some developers give money? Well, one of the reasons is that my project uses their projects. So it's all about dependencies in this large software ecosystem. Or I had no more time to help with coding, so I decided to sponsor. So it's a way of contributing to open source that does not require a lot of time, but it does require some money, of course. I just want to highlight one opportunity that's really interesting for future work. So something that GitHub Sponsors has enabled, and I think it existed before GitHub Sponsors as well, but it's probably become more popular now, is what's called sponsorware, which is one open source release strategy where basically you say, I'm not going to release my software until I have obtained a certain amount of sponsorship. So I think there's a lot of interesting future work in trying to understand how this is used and how this is perceived by the open source community. This is my last slide. I'm not going to read it out. But basically, we contributed a mixed method study of this new thing called GitHub Sponsors. We find that developers are often clustered around sponsorship, and sponsorship is often seen as a token of appreciation and recognition, or it's meant to be for the good of the entire open source community. That's it for me. Thanks for listening.
Thank you. Okay, so now we're going to open up the floor to questions. You have your choice of just shouting your question out, or you can type it into the chat, and then I will ask the question of the appropriate speaker. If you do choose to type it into the chat, then please make it clear who this question is aimed at. Otherwise, we'll all have to guess. So I'll begin just to get the ball rolling, and while you guys are thinking or typing. In fact, let me just start with Christoph, since you were the last speaker. So you mentioned some incentive mechanisms. So money is an incentive, but you're saying the money is small. Fame is an incentive. Fame doesn't require money. There are other mechanisms out there that essentially trade free contributions for cash, like Patreon. So what do you think? Do you think that GitHub Sponsors has explored the space of possible incentive mechanisms, or is it just this is what we thought of and we threw it out there?
Yeah, I think the latter is probably a pretty good description of what's happening there. I mean, as you can imagine, because it's branded under the GitHub umbrella, it's really tightly integrated with GitHub. Unlike many other services where you would have to go outside of GitHub, you have to figure out if you actually trust that site and so on. And like I said at the beginning of my presentation, GitHub does match contributions at the moment up to a certain amount. So there's a bit of incentive to stay within that same platform using GitHub to sort of send this token of appreciation and recognition. But yeah, as you said, there's many things that can be done, and there's buy me a coffee and things like that have also been used for similar purposes. But I think it's interesting to explore, what are sort of the impacts of even these really small amounts of money on motivation. Do people actually go and develop more features, fix more bugs, and so on because they get this kind of money? Something that I didn't have time to cover in those 5 minutes, but we did ask a little bit in the survey also about the expectations, and in some cases there was a bit of a mismatch, and that the people giving money were actually expecting that there would be something in return, maybe more development, more bug fixes, whatever it might be, whereas the people receiving it were just like, oh, this is great. Thank you for the appreciation. It doesn't change anything about what I'm doing, but I appreciate being recognized. So I think that's also something to explore a little bit in future work.
This isn't a question, but just a thought that I'm assuming that there's a lot of research on motivation in the organizational management literature. And so that might be something you might want to look into for future work.
Absolutely.
There's a question in the chat for Patricia. Great work. Do you find differences in how men versus women were receptive to these strategies?
Well, thanks for the question, Matthew. I don't know if I mispronounced, sorry. But in any case, I didn't find any differences. For now, we have preliminary results from the focus group, and I saw that women engaged with the lenses and gave their opinion about the lenses as much as men. So I didn't see a difference regarding this. Right now, we are starting to run an experiment with the digital simulation. We already implemented it. So maybe in a few weeks or months, I don't know, I'll be able to answer about this. And thank you for the question.
Another question for Christoph, which is regarding gender diversity in the sponsorship data. Do you have any data?
Not yet, no. The amount of data in general is probably a bit too small to come up with definite conclusions anyway. And as you might be aware, a lot of research on gender in the context of GitHub had to go through quite a bit of effort to basically guess people's gender based on the very limited information that's often available in the GitHub profiles. So no, we haven't gone down that route just yet. But I think that's interesting future work as well to see, maybe not just in terms of gender, but in general, what kind of information do people make available about themselves and how does that impact the amount of sponsorship that they might receive? Good question, thanks.
We have a question for Etienne. How do the quantity and quality of training data affect few-shot learning?
The data from the open source work. And you can find the project on GitHub.
So did you hear the question? Etienne, did you hear the question?
No. The question? What's about
Yeah,
the question?
the question was, how do the quantity and quality of training data affect the few-shot learning?
The quantity and the quality of the few-shot learning, the data.
The data. How does the quantity and quality of data affect the learning?
Oh. The data we use to few-shot learning is the Solidity and the SQL. Yeah, it's in there.
Right, but the question was, do you have any idea about how much data you need, for example, to get a good quality result out of the learning?
I decide the data size according to the common language, and the common program language is all about the number of the common language data size is always about maybe okay, I see 100,000, and I choose the number of few-shot learning data is 10,000. I think that is
Okay, thank you. Let's see. I'll ask another question of Yuan. So the idea of using the code snippets, what is your main motivation for that? Is this about being able to use them more effectively in education? Is this so that people can take code snippets and insert them into their code more confidently, understanding the constraints, or something else?
Yeah, when we designed the project in mind, we definitely had saving developer time when they copy code from Stack Overflow into their code base. Hopefully, we'll be able to save them a little bit of searching. But I guess secondary objectives that I have in mind, though I don't think quite fully addresses. Well, a lot of papers recently have looked at code snippets and how it's been incorporated in GitHub, and hopefully we can help improve the accuracy of future research in that kind of regard.
Great, thank you. Oh, I see. I missed a question for Christoph. Do you have any opinion why GitHub didn't want or couldn't reuse existing platforms?
That's a good question. I don't think I have empirical evidence or even hard data on this. Looking into it in a bit more detail, because it requires actual money being transferred back and forth. I think country-specific tax laws are a big issue there. A big thing that, in this case, GitHub needs to worry about. And I think the GitHub sponsors at the moment is available in just under 20 countries. I should look this up again. But they basically rolled it out, country by country, as I'm sure they were figuring out tax implications and all of that. So I'm sure there's sort of legal aspects related to this that make it a lot more complicated than just saying, oh, well, buymeacoffee.org and use that one. So I'm assuming a lot of that is going on in the background that makes these things complicated from an tax and economy perspective that have nothing to do with software engineering immediately.
It's a business after all.
Can I ask
Sure,
a question for Gunnar? Because we were in the same session yesterday, so we are going to continue the discussion. Did you think, or do you have anything from the literature relating compiler warnings to code smells? Because I think it's probably, if you have a lot of compiler warnings, that will be, I imagine, a code smell. I'm not a specialist on this, so did you think of this?
Yeah, so I think one of the problems is that research related to compiler warnings is kind of limited. The only paper we were able to find was the one which said that the more warnings you have, the more there's some sort of a maybe correlation that file contains more defects. But there's nothing else. I mean, we thought about maybe kind of using static analysis research as a proxy, but like code compiler warnings and static analysis are two very different beasts. They may be similar in concept, but in real life, they're two very different things. I mean, generally, my pure anecdotal empirical evidence is that compiler warnings are indicative of code smell. Random variables, random names, things out of scope, random conversions going on, headers double included. Usually my take is the more warnings we have, there seems to be some sort of problem. So I usually use it kind of as gut feeling indication that things are not quite right. That's the best I can tell you. But at the same time, you ask another engineer with the same amount of experience, they're going to tell you compilers don't know anything. It doesn't matter. We don't care.
Okay, thank you.
Yeah, actually, I have a couple of questions.
Fascinating, given that compiler warnings have been around for decades, that there's so little empirical evidence.
It is sad.
I have actually a follow-up question for Gunnar. So
let me ask a question of Chao Liu. So have you done any comparison with, let's say, more obvious lexical analysis lexical clustering techniques like LDA or TF-IDF in terms of identifying important terms, important concepts, important keywords, and just wondering how you compared to those relatively simple strategies. Something not nearly as complex as deep learning.
Thanks for the question, Dominic. Compare our work with LDO and the other methods. We just compare our method with code search, existing code search studies and online search engines. And the clustering, I think it will be helpful for the code search, and we are working on it. And maybe it will come in the future.
Okay. Okay, thank you. Oops.
Thank you.
So let's see, Gunnar, do you have a data set of how developers are handling these warnings? That would be helpful for the refactoring community.
No, unfortunately not. So the main root problem is that conducting any type of studies like this inside industry is extremely expensive. So it means recording, figuring out what people do, conducting surveys. And usually we don't do it unless it's related to high priority security bugs. So there is no data. I mean, all of our observations are just purely kind of based on random teams, random companies, but unfortunately, they're kind of all very, very similar. So, but yeah, there is no formal data set. If anybody wants to work on getting it, I'll be absolutely open. I'll be more than happy to work with anybody who wants to make more progress, because as somebody who has suffered many years because of compiler warnings, I want to ease that suffering.
Thank you. Thank you.
Okay, thank you.
You can hear me, right?
I have a question for Patricia. So is the lack of empirical evidence surrounding negotiations a stumbling block? So it seems to me that if I had a strong empirical foundation saying, this is how long it's going to take, and here's why I believe that based on a database of historical evidence, similar systems, something like that, then there really isn't much negotiation. It's like, you want this done, here's how much it's going to take. You know, I think in terms of medicine, if your doctor says you have diabetes, you don't argue with them about, well, you know, that's not very important to me. You know, it's not something you negotiate. It's like, I have a disease, I have to do something about it. But that's because they have a very strong epidemiological basis of knowledge in medicine. So what's your thought on that?
Oh, that's a terrific question. I loved it. And well, I totally agree with you in the sense that, well, that's the logical thing to do. The rational thing to do is to accept what someone who has the technical knowledge, and there is data about it sometimes. But we are talking about people in organizations and business markets. They are pressured. So sometimes they just don't listen. So, and I also loved your analogy with the doctor, because, well, the doctor might be telling me that I cannot drink, for instance, anymore. Otherwise, I am going to die. But, you know, actually, there's nothing the doctor can do about this. You know, the patient has to do something. And in the case of software developers, they are in a worse position than the doctor, because, you know, they will have to live with the problem. And I think that when we are looking to negotiation, we are looking to provide these estimators and software developers, anyone providing the estimate, with tools to try to show the patient that the best thing to do is to stop drinking or take the medicine, and, you know, instead of simply yielding to pressure, because sometimes, well, many times, the estimator is on a less powerful position. So sometimes they have to accept. And what we are proposing here is, well, let's try to use some other ways. Try something. For instance, we can try to understand better the pressure. Why does this person want this thing and this deadline? And then understanding why, we can start thinking of, well, are there alternatives, right? Can I reduce scope somehow? I don't know. We can think of alternatives and propose that. And with the example of the reality test lens, for instance, you are actually, instead of telling the person what's going to happen, the problems we're going to face, let's think together. What do you think will happen? Because then the person start to think about that with you. You know, they engage in a conversation. A negotiation is actually a conversation, you know. And so I think with this, we have a chance to overcome this human and social issue, because it's not a technical issue, you know. It doesn't matter for me, the method, the estimation method the person is using, whether they have historical data or not. I want them to get a set of skills to overcome not the technical challenge, because it's still a technical challenge, but the social and human challenge we have here, you know. And that's it. Thank you very much for this question.
Great answer. Thank you. I remember for years when I would fly somewhere, I would pull out the in-flight magazine from the seat pocket. And there was, for a long time, an ad for negotiation seminars. And they always had this headline: in life, you don't get what you deserve, you get what you negotiate. And I think that this is an example of that, you know, and why I always try to teach my students that the soft skills, communication and negotiation and persuasion and presentation and all these things, are just as important as your technical skills and your ability to set up a markup model or something like that. So I certainly appreciate this work.
It's a step towards soft skills. It's a concrete step we're trying to give.
Yeah. Other questions?
I had a question for you, if I can.
I'll ask another one if no one is welcome. Sorry?
I think Matthew had a question.
Yes. Can you hear me?
I can.
Okay. Yeah, it's maybe a bit out of the blue, but about the motivation for your work and related to very personal experience. When I go on Stack Overflow,
I think I've read all of Matthew's questions.
I can type in my question if you want.
Rick, can you hear Matthew? He was talking.
Oh, sorry. Go ahead. I didn't hear anything.
I've been having some issues just now, so yeah. But when you can hear my question?
Yeah. Yeah.
Now I can hear you. Something
okay, great.
weird is going on with Midspace.
Yeah. So yeah, I was saying when I go on Stack Overflow, usually I can sort of easily identify the types, which are usually the most common types. So can you maybe expand a bit on the motivation, how hard it is to actually find these types compared to, let's say, just using the most popular type? If you have some ambiguity, is it in 50% of the cases the type will be ambiguous and not the most popular one, or maybe 80%?
I don't have any concrete numbers for you, unfortunately. But in some previous studies, I believe they have found that a lot of Stack Overflow code snippets are actually outdated, using outdated APIs and library versions, in which case just using the latest would not work. And using our technique, you can say, okay, it depends on these methods and these types, and we'll be able to help you find what library you might need, which may not be the most popular and latest one that's out right now.
Yeah. I didn't consider the versions. Thank you. Yeah, because you showed this baseline approach that had, I think, below 50% precision, and it was surprising to me, but then it makes sense.
Yeah, I think it's a little. Yeah, it's around a little higher. I think 60.
Yeah. Well.
Yeah.
About that, but I remember being surprised by it.
Mm-hmm.
Thanks.
Cool. Thank you.
Other questions?
I may make a kind of a general comment. Christoph, thank you so much for your research. I mean, it's something kind of I find valuable from purely practical point of view, because so one of the things why in industry you don't want to touch open source is kind of purely legal, related to licensing, because you have all kinds of implications with license. But once licensing stuff is figured out, the second problem is technical. You have no assurances that, for example, the library you use or tool you use, somebody's going to fix the bugs, somebody's going to respond, and there's going to be at least somebody working on it. I hope that sponsorship program somehow helps to kind of alleviate this issue, because otherwise it's you're pretty much gambling. Your entire gamble is that, okay, nobody's going to work maybe on it for 6 months from now. You have to have your own engineers understand the entire code base. So I'm grateful that you're looking into this. It's going to make hopefully life much easier.
Thanks, Gunnar. I think especially sort of this expectation management around this is sort of a really interesting area for future work. Because even if at the moment companies were to use GitHub sponsors to give money to the libraries that they depend on, there's no guarantee whatsoever that the other side will actually receive it and realize that they want me to do something in return, right? Because that's not how it is set up at the moment. And obviously, because ultimately everybody is still a volunteer, it's not payment, it's a donation, it's not payment, right? So how to manage those expectations will be a really interesting way to explore this in the future.
I actually have a question along that lines. Is it a concern that developers are being sort of sponsored instead of being hired by companies like Red Hat to develop software? It seems to me the trend is.
I think there definitely could be some of that. I think at the moment, at least, the amounts of money that are being exchanged via GitHub sponsors are much smaller than what you would get if you were hired by a company. So I don't think they are in direct competition just yet. But I think as GitHub sponsors, and what I was talking about towards the end of the presentation, sponsor where people basically extract money from you and won't release it until they have the money. As these things pick up and maybe become more popular, maybe the amounts of money involved will get more as well. I think that'll be an interesting space to watch.
Cool.
Yeah, it's sort of interesting because in many ways, sponsorship is something that doesn't immediately fit into the open source model. It is a volunteer-driven thing, and money wasn't really the driving factor behind any of this when open source started. It's sort of a bit of a mismatch, and it's kind of interesting to see how this plays out now. Thanks. We'll do lots of future work on this. Thanks everybody for their input.
Thank you. Probably have time for one more question. Quick question. I'll ask one if no one else is. So this is to Etienne. When you gave your talk, it struck me that part of what you are talking about depends on how close the model that you train is to the model that you're making predictions of, right? That was your idea that, well, we've never seen this language before, but it's kind of close to this other language. And this seems similar to model drift, the problem of model drift in machine learning. So do you have a way of gauging that drift or that difference between the target and the the trained model?
We're using the meta-learning method, and the method we use is to extract information about the code search task. And we not focus on the information in the specific language, like the information in Python or information in Java. We're using the method